Kirchhoff's current law. Kirchhoff's current law. Kirchhoff's current law. Kirchhoff's current law in a closed electrical circuit the algebraic sum of all the current should be zero. Should be zero. Next property of KCl is it is based on conservation of charge. So KCl based on the principle of conservation charge. On the other hand, voltage KVL is based on the conservation of the energy. Another property of KCl is that it is applicable in parallel circuit. In KCl, nodal analysis is used. Right? So we can take an example of KCl for solving numerical problem. KCl is all the current entering in a node is equal to all the current passing through that node. Take an example. Let's take a node, all the current entering here, I1, that is the leaving current, I2, I3 and entering I4. So entering current I1, this one entering current I4 is equal to leaving current means outgoing current equal to I2 plus this one I3. I1 and I4 entering current is equal to leaving current I2 and I3. This is the basic rules of Kirchhoff's current law. Let's take an example of KCl. We solve a numerical problem. Here 40 volt, 4 ohm, 10 ohm, 5 ohm, and put here value of 20 ohm. So by using KCL, find out the current in 10 ohm resistance. In 10 ohm resistance. So how we find out the current in 10 ohm resistance using KCL? This is the problem. Here we take nodal analysis. In KCL we take nodal analysis. How many nodes present there? This one we can take VA node, and this is a grounded potential here 0. So here potential will be 0. In node VA, entering current, we two signs included. If current entering in a node, current entering in node, sign will be negative. Current outgoing in node, sign will be positive. So if we take current I1 here, I2 here, and I3 here, these three of current leaving the node means outgoing from this node VA. So all the signs will be positive. If we can take any direction of the current, answer will be same. You can take any direction of the current, means I2, direction of I2 will be here, but if you take direction of the I2 entering the node, so this will be sign negative. This is the basic fundamental of positive sign of current and negative sign of the current. So we applied KCL at node VA here. VA here, higher potential to lower potential upon total resistance. Here I1 outgoing current plus I2 outgoing current plus I3 also outgoing. So these are three positive sign is equal to 0. According to Ohm's law, I is equal to V upon R. Higher voltage potential minus lower voltage potential. So VA minus lower 40 upon this one 4 ohm plus. How to calculate the value of I2? I2, this means higher potential minus lower potential, VA minus 20 upon 5 ohm resistance plus I3, this one higher potential VA minus, here grounded potential means 0 upon total resistance 10 ohm. This is a nodal analysis is equal to 0. Here we calculate the value of VA. Take a common 1 upon 4 plus 1 upon 5 plus 1 upon 10 minus 14 is equal to 0. After solving these equation, VA is equal to 25.45 volt. What is the question asked in this numerical? What is the current flow in 10 ohm resistance? So, in 10 ohm resistance, how to calculate current? Current is equal to V upon R. In this branch, voltage VA minus voltage of here 0 and resistance is 10 ohm. Put the value of VA here 45 upon 10. So current value in 10 ohm resistance is equal to 2.54 ampere. So this is the basic fundamental of Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's voltage law based on the principle of conservation of the energy, whereas Kirchhoff's current law based on the conservation of charge. These two numerical basic concept, we have understand all the concept regarding Kirchhoff's law, Kirchhoff's voltage law and Kirchhoff's current law. Next topic will be discussed later. Thank you.